Hello. Hello students. Today we are going to study problems in current electricity. A current of 5 ampere exists on a 10 ohm resistance for 4 minutes. 5 ampere current for 4 minutes. How much charge pass through any cross section of the resistor in this time? Q equal to IT. Current is 5 ampere. Time is 4 minutes. Minute means 60 seconds. This is 5 into 4, 20 into 6, 120. This is 1200 coulomb. So out of 4 choice, the correct choice is option 3. The resistance of wire is 20 ohm. The wire is stretched to 3 times its length. Then the resistance will know. Whenever mass of the wire is constant, whenever in any question it is written that stretching the wire means mass remains constant. If its length will get increased, then definitely cross section area will get decreased. Okay. So whenever length increases and mass remains constant, resistance proportional remains proportional to L square. So it is stretched to 3 times. New resistance will become 9 times. So resistance will become 180 ohm. Okay. So out of 4 choice, the correct answer is R dash upon R equal to 9. So R dash will be equal to 180 ohm. So out of 4 choice, the correct choice is option 4. In the following diagram, two parallel pipes A and B are of same thickness. The arm of B is double that of A. Compare these resistance and find out the value of RA and RB. Dear student, in the direction of electric field, we have to take length and R written as rho L upon A. Okay. So here R1 is what? Rho A upon AT. And what is R2? Rho into 2A. Rho is resistivity upon 2AT. So you can see 2 will get cancelled. So this will be same. Okay. So R1 upon R2. Ratio equal to 1. So out of 4 choice, the correct choice is option 1. Net resistance between X and Y is because here this is zero resistance wire. So complete current will pass here. So R and R will be in series. So total resistance will be only 2R. So after 4 choice, correct choice is option 2. So answer 2 is the correct answer. Net resistance between X and Y is now in the circuit. You can see 30 ohm, 30 ohm, 30 ohm. They are connected in parallel. So this will become 10 ohm. This is 20 ohm. Because zero resistance wire, so this 10 ohm will bypass. This is X and this is Y. And now again 10 ohm, 20 ohm. This is 30 ohm. And this 30 ohm will bypass. This is like this. So 30, 30 means this is 15 ohm. Okay. So out of 4 choice, the correct answer is option 3 is the correct answer. Net resistance between X and Y is, dear student, this is 2 ohm and 5 ohm are connected in series. 7 ohm and 6 ohm are connected in series. So the diagram will become like this. This is 5 ohm, 2 and 5, 7 ohm, and 7 and 6, 13 ohm. And now 7 ohm and 13 ohm are connected in parallel. 7 plus 13. So this will give 7 into 13 upon 20. Approximately 3, approximately more than 4, something like that. So 4.55. So approximately we can take 4.55 ohm. So out of 4 choice, the correct choice is option 2. The equivalent resistance between the terminal point P and Q is 4 ohm in the given circuit. Then find out the resistance of R in ohm. Now you can see here R, they are in parallel. So this will become R by 3 and R is in series. So between P and Q, if you draw the diagram, this is R by 3 and this is R, this is P and this is Q and this is R. So 4R by 3 and R in parallel R1 R2 upon R1 plus R2. The equivalent is given 4 ohm. After solving this equation, we will get 4R upon 3 divided by 7 equal to 4. 3 will get cancelled. So R will be equal to 7 ohm. So out of 4 choice, the correct choice will be option 1. Option 1 will be correct answer. Option 1 will be correct answer. Okay. Hope you understood. This point and this point is at same potential. So R are in parallel. Okay. They are in series and they are in parallel. Okay. For the following circuits, the potential difference between X and Y in volt. Now you can see here in this diagram, this 2 volt is the potential difference across this 6 ohm and across this 6 ohm. Okay. So here you can see here, this is 2 volt. In this branch, how much current will be there? 2 upon 6, this is equal to 1 upon 3 ampere. And in this branch, how much current will flow? This is again 2 upon 6, this is again 1 upon 3 ampere. Now, we can solve the problem by writing KVL Vx, because current is in this direction, current is in this direction. So, opposite to current Vx plus 1 upon 3 into 2 minus 1 upon 3 into 2 minus 1 upon 3 into 2 equal to Vy. So dear student, this will get cancelled. So Vx minus Vy, this will be equal to 2 upon 3 volt. Okay. So out of 4 choice, the correct answer is option 1. For following circuit, the value of total resistance between X and Y in ohm. Dear student, this is a balanced resistance because P upon Q equal to R upon S. So this 2R will get cancelled. Okay. R and R are in series. So this will become 2R. And this R and R again in series. This is 2R. And 2R and 2R will give you equivalent R. Okay. So out of 4 choice, R1 R2 upon R1 plus R2. So this will give us R. So out of 4 choice, the correct answer is option 1. Five identical resistances are connected as shown in figure. The equivalent resistance between point A and B. Dear student, in this diagram, you can see all are connected in series. R. So equivalent resistance is how much? This is 5R. So very simple question. Out of 4 options, the correct answer is option 2. The effective resistance in ohm between B and C of letter A containing resistance is shown in figure H. Now you can see here 10 ohm and 10 ohm are connected in series. So this is 20 ohm and this is 10 ohm and this is 10 ohm. This is 10 ohm. This is B and this is C. Now we can see here 20 and 10 are in parallel. So 20 into 10 upon 20 plus 10. This is 20 upon 3 ohm. Now 10 ohm plus 20 upon 3 ohm plus 10 ohm are in series. This is R equivalent between B and C. So this is 20 plus 20 upon 3. So this is how much? 80 upon 3 ohm. So out of 4 choice, we can mark option 3 as correct answer. So option 3 is the correct answer. Four identical resistances are joined as shown in figure. The equivalent resistance between points A and B is R1. The equivalent resistance between points A and C is R2. Then ratio of R1 and R2 is. Dear student, in this diagram you can see between A and B it is R1. So 1 ohm, 1 ohm, 1 ohm. These three are between A and B. See, this is the picture. This is 3 ohm. So R1 it will be equal to what? 1 into 3 upon 1 plus 3 means 3 upon 4 ohm. And now between B, A and C, this is the picture. This is 2 ohm and this is also 2 ohm. So R2 will be equal to 1 ohm because they are in parallel. So we can easily find ratio R1 upon R2. This is equal to 3 upon 4 ohm. 3 upon 4. R1 upon R2 equal to 3 upon 4. So answer is option 3. Out of 4 choice, the correct choice is option 3. Okay. In the adjoining figure, there is no deflection in the galvanometer, then R is equal to, when there is no deflection, means what? Potential at this point and potential at this point should be same. Means this should become the case of balance Witterstone bridge. Means 2 upon R should become equal to 10 upon 30. So this is equal to 1 upon 3. So R equal to how much? R equal to 6 ohm. So out of 4 choice, the correct answer is option 3. In the following circuit, the resultant EMF between AB is voltage always gets set up in parallel, potential difference remains same. So E equivalent will be polarity is same. E equal to E1 plus E2 plus E3 plus E4. Okay. So this is the answer. Out of 4 choice, the correct choice is option 1. An electric bulb is rated 220 volt and 100 watt. The resistance of the filament of the electric bulb is. Dear student, resistance can be calculated by V square upon power. This is 220 into 220 upon 100. 0, 0 will get cancelled. So this is 484 ohm. So out of 4 choice, the correct answer is option 3. If the current in an electric bulb drops by 2%, then the power decreases by. Dear student, relation of power, resistance is fixed. So delta P upon P into 100 equal to 2 delta I upon I. Into 100. Since in the question current drops by 2%, so power will drop by 4%. So out of 4 choice, the correct answer is option 3. Two electric bulbs rated P1 watt V volt and P2 watt V volt are connected in parallel across V volt mains. Then the total power is. In series, in parallel power gets set up. So P will be equal to what? P1 plus P2. So out of 4 choice, the correct answer is option 1. Two cells of same EMF E and internal resistance R are connected in parallel with the resistance of R. To get maximum power in the circuit, the value of R is, whenever this is maximum power transfer theorem, maximum power is reduced when external resistance remains equal to effective internal resistance. So here in this case, the circuit diagram will become like this. This is E, this is R by 2 and this is R. So for maximum power, R should be equal to R by 2. So dear student, out of 4 choice, the correct answer is option 1. Five resistances are connected as shown in figure. The effective resistance between point A and B is. Dear student, this is 2 upon 3, this is 4 upon 6, means ratio is same. So this is case of balance Witterstone B. So for 7 ohm will not come into picture. So 2, 3 are in series, so this is 5 ohm. 5, 4, 6 are in series, this is 10 ohm. This is 8, this is B. 5 and 10, R1, R2 upon R1 plus R2. This will get cancelled by 3. So answer will be something, 10 by 3. So out of 4 choice, the correct answer is option 1. Okay, here correct choice is option 1.